Stuff. I guess I'm just, after
You were swearing the other day in class.
what?
You did.
You
said
said
a
the
swear
S
word.
word. Yeah, was it that?
Yeah, I
S
did.
word?
I did.
Yeah,
I
exactly.
did.
So said
I said shoot.
No, you said
Anyway.
shit.
All right. So now you guys made me forget what I was going to say. Oh, seniors, your final exam will begin tomorrow. Okay? You will have tomorrow and you will have Thursday, because today's Tuesday, to finish it.
Finals on it tomorrow?
They have a different version of our final.
Oh, okay.
So similar, they're going to be doing the same things, but they're going to have different questions that we will have. Okay? So, oh yeah, speaking of questions that we have, ladies and gentlemen, here you go. I want you to figure out what current element is in these spots. So take out your stuff.
I don't know.
Here's your wonderful quizzes back, ladies and gentlemen.
I got a 6 out of 10 on the
It's actually okay. We forget.
It's over.
Yeah, I'm actually
Don't tell
Well, at least you realize it.
I popped
No,
up.
I'm just getting
I
past
forgot that
people
even
already.
happened, to be honest. Like, I think I blocked it out.
No, it's not. Alexis?
It's not mine.
No, it's not. Cynthia?
It's not
No, it's not. Rose?
mine.
No, Cincy's.
Wait, why is it?
I was not ready for that.
Got it. Angel?
Yeah, girl.
Did you go see Mr. G?
Yeah.
Okay.
I have a pass from her.
No, that's fine. I just remembered you were supposed to be there today. Sophia?
Is that mine?
What's the chocolate table? Is that? Oh,
No, you're being mean.
wait, let me see if you.
I did ask. You didn't hear me.
No, you didn't. Nice try. Hey, stop laughing. I don't have none of that in
Put
class.
+1 and +2.
Knock it off.
I'm sorry.
No, you're not, because you're still doing it. If you were sorry, you would correct the behavior and wouldn't be doing it.
Or the non-metal change.
Just the way you pointed it out was so funny.
I did not know.
I didn't even know what to do for this one.
No.
Yeah.
Yeah, no,
Yeah.
it's-
It's okay.
I didn't know what to do. I was like, I don't know.
Yeah, this is 1, 2, 3.
Angel?
Hey, Luce, it's not 0.
Whatever.
I didn't say I guessed.
No.
I guess you're right.
Those are the practice tests that I'll be going over with them, but there are clues that there that you can look at that will help you. By the way, you are supposed to be doing these 6 questions, ladies and gentlemen, and figuring out what current element is in those spots. So let's go.
It's okay. Usually right on the final.
I would
Nobody
say
asked Sophia.
My
Nobody else just got. It's
I don't know. I don't know what that's.
It's actually great. Girl, none of us passed.
Are you kidding? There were people who had perfect scores on that quiz.
No, not. I saw us 3. Mr. Brand.
Well, there's more than you 3 people in the world.
Okay, well,
Get over yourself, Alexis.
you can't just listen into part of my conversation and then
Actually, I can. I did.
like
What?
insert yourself.
I want to eliminate it. It said monatomic. Oh.
I defined it for you last week and even had you put it on your periodic table.
Oh, okay.
Hopefully.
I'm actually done with this.
I don't know.
Yeah, that should be fine. Let's see. How much did it affect your grade?
It's really good.
It's good.
I feel like the chicken from
I said.
I don't think you did.
It just seems so bad.
What's wrong with the one that's sitting there, not even charging?
Oh, I did.
Wait, Mr. Brand, don't you just love it here?
Mr. Brand, I have a question. What's a monatomic element?
Right, I don't think
Well, what does mono mean?
One.
What is atomic?
One atom.
Good. What family is one atom?
Hydrogen.
Well, you know what the diatomics are, right?
2 atoms.
Okay, so monatomic would be one atom always. Only one atom. No, hydrogen's a diatomic. How can it be a monatomic?
Is it helium?
It's one of them.
Oh, so
There's
it's
more than one.
Wait, but how do we
There's a whole
know?
family of them.
You said they didn't have 8 valence electrons, but 1, 2, 3, 4, 5.
So monatomic will get you into a certain family of the periodic table.
The noble gases.
Okay, yeah.
So which
Yeah,
one?
but they have 8 valence electrons, don't they?
No, helium doesn't.
No, helium doesn't. That's why I said helium.
It's helium.
Come on.
Okay, but you said a word. What am I supposed to respond to?
Yes
Okay,
or
so
no?
the final thing we're-
Yes, helium is a word. Okay, there, yes.
Oh my gosh, no, you're evil.
We should do partners on the final.
I agree.
Oh, no, you don't want that.
We should do.
Yes, I do.
We should do the.
Well,
whole
we used to do
process.
partners on labs. That didn't work out well.
Don't
Hey,
we
so
do
we're
partners
both
on
being
labs?
able to help each other?
You're wasting your time. Get done. Here's the thing. You will only get better at these things if you practice. And I'm giving you clues that I'm going to put on the test.
D orbital. That's 3, right?
That's the D's. So these are
The D's, yeah, the D's. That's the D's, yes.
Yeah,
The
but
D's
the
are
number
the
that
D's.
represents a D orbital. I thought that was 3.
Is that 5? I thought 3 was.
It's 3. It's 3.
There's 5
Orbitals of
orientations.
You're confusing how many orientations there are with the number that represents the letter.
So then is it
There
10?
is a number that represents the
one.
letter.
It's
For an S, it is what?
1.
S is 1.
No.
Oh, S is 0.
P
S
is-
0. P is 1. D is 2.
Oh, so
F
it's
is 3.
3.
Okay.
So it's 2. So it's in the same period. It's in
Second
period 2.
period. SP3.
0.
Oh my god, that's on that.
That's what we just talked about on Thursday of last week.
Low key, I was not paying attention. I'm not gonna lie.
Oh,
Well, I'm not going to lie then. I really can't help you.
Nitrogen?
I did
I
not
didn't
ask
write that
how.
table.
Oh, okay. Good.
Nitrogen. I need that chart. I claim.
Oh, it's carbon. Oh, wait. Yeah, it's carbon.
Yeah, Cynthia knows what she's talking about.
Conversation.
What is a
Wait,
bent
isn't it
geometry?
nitrogen? I'm confused. It's on that table, that big table on the side show.
Oh, wait.
Wait,
it's in the oxygen family. Which one's the oxygen family?
No, it's not. It's in the
it's in the
nitrogen.
second
family. It's in the
It's in period.
Maybe I should let you do it as a class.
Is this
We're
what-
struggling right now.
Guys, I
but
swear to God,
for
it's
bent
nitrogen.
geometry. For bent geometry is either oxygen family or
It's
the
nitrogen.
carbon family. You take with the
No, it's not either or.
It's the nitrogen.
Don't use the degenerate. Don't use the non-degenerate orbital.
It's the nitrogen one.
Just
It's
kidding.
the nitrogen family, you guys.
From Aries as well.
Which
Wait.
one's the nitrogen family?
I love
The
your
one with
confidence.
nitrogen.
Give him a high five, Alexis.
I love your confidence.
I swear
You're
to
wrong,
God.
but I love your confidence.
Are you seriously?
Seriously.
I wrote
hydrogen-
down
or the
bent.
nitrogen family is not the bent
It's
geometry.
SP3.
I wrote
Oxygen
down
family
bent.
is a bent
What?
geometry.
I wrote down bent.
You wrote it down in the wrong spot then.
Oh,
So then
I
it
can't
has
do
to
this
be-
anymore.
You haven't done it to begin with. You can't say any more if you haven't even done it at the
I
start.
wrote this
You
down.
will not see my face in this class again.
Same period as the
I
nitrogen.
can't do it. I can't.
So it's a SP3 hybridization.
It is not a
It's oxygen. I swear if it's not oxygen, I'll leave this class right now.
It
Never
can't be
mind,
oxygen. It's in the second period.
I'll leave tomorrow. I have a game today.
Oxygen when it's in the second period. Oxygen's in the second period. You're looking at the
Oh,
family.
I was looking at the family.
Okay, it's either carbon.
Okay,
It's either carbon.
before we go through these, ladies and gentlemen, let's take a look at that quiz that you so wonderfully enjoyed. Now, if you hadn't been quite so, what's the term I'm looking for? I can't use that term. If you hadn't acted like somebody peed in your Cheerios the other day when you took the quiz, I was going to tell you that the only thing the quiz could do is actually help your grade. Because I was going to tell you that by giving you that quiz, I was then going to drop your lowest quiz score for the entire trimester. And I only graded the quiz out of 10 points instead of 12. So the score that you got is out of 10 and not out of 12. So if you got a 10 out of 12, you actually got a 10 out of 10, which is 100. Which means I'll be dropping a different quiz because obviously that's not going to be your lowest score. So here are the answers to your quiz. And by the way, this is something, ladies and gentlemen, Aiden, take out your headphone, please. This is something you should know. If you don't know how to do this, we spent a week writing electron configurations. We spent a day and a half talking about the K, L, the M, the N, the O, the P, the Q. And we also talked about isoelectric and told you it's going to be on your test. So again, this is the stuff that you are going to be doing on your test. So Just so that you are aware of it, ladies and gentlemen, that is what's going on. Thank you very much. So here you go, ladies and gentlemen. The one on the left-hand side over here is version A. This is version B in the upper right-hand corner. You can see they're very similar. Okay? There are your configurations. There's the KLMNOPQ. For these down here, ladies and gentlemen, I do not have an answer down here. Why? Because I can't, because I let you pick whichever element you wanted. But let's say, for example, you picked magnesium. Okay? If you pick magnesium on the periodic table, ladies and gentlemen, your answers would have been magnesium. Charge when stable, magnesium is a +2. Electrons when stable, magnesium has 12, but to become a +2, it has to lose 2, which means it would have 10 when it is stable. What is magnesium isoelectric to? Well, when it's down to 10 electrons, it is isoelectric to neon, ladies and gentlemen. Okay? Now, if you chose to pick a nonmetal, maybe you chose to pick selenium. Selenium becomes a -2 ion when it becomes stable, which means then it will have 36 electrons instead of the 34 it normally has. Well, when you have 36 electrons, ladies and gentlemen, you look just like krypton, and that is what isoelectric means, is you have the same electron configuration as them. Okay? Now, Olivia, Rocio, Angel, who's my other senior? Avan, who's not here. I gave you a packet today, ladies, that has in it sample questions that is going to be on the test. Because obviously, with you guys leaving early, you're not going to get as much practice time as somebody else. Okay? So I gave you the sample questions. You could try to work it onto these periodic tables as you want. But to be honest, if you stop by and see me after class, I can go in, look at the computer, and tell you what grade you need to get on this to pass the class. Okay? For some of you, it's a 0. For others, it is not. Okay? And I will do the same for the rest of you next week before you take this final, letting you know what you will need. Now, I will tell you this. Some of you are going to need to invent a time machine to go back in time and do the things you did better so that you can get a passing grade, because even if you get 100% on this, you're not passing the class. So, but that is a situation that you have put yourself in, not me. So, questions, ladies and gentlemen? Questions on this? No questions on the quiz from last week. Again, yes, sir.
How do you do the NLP?
How do I do the what?
NLP? Where'd you get the numbers?
This part here?
Yeah.
Oh, again, remember, for krypton, we are going to use the numbers that are next to krypton above your head there. What are they? 2, 8, what? Find krypton, element 36. 2, 8, 18, 8. That's how I started this. That takes care of the krypton part. Then in the 5th energy level, there are 2 more electrons. 1, 2, 3, 4, 5. Put my 2 in here. In the 4th energy level, along with the ones that are already here from krypton, I need to add 5 to it. Since there was an 8 here, when I add 5, that becomes 13. Okay? For this one, for xenon, it was 2, 8, 18, 18, 8. Now I need to add 2 more into the 6th energy level because of the 6 here. So there's that 2. I need to add 1 more into the 5th energy level because this is a 5D1. So this had an 8, I made it a 9. This had an 18. I'm adding 2 more to the 4th because it ends 4F2. That makes this a 20. Over here, The exact same things, except our F was a little bit bigger. It was an F5 instead of an F3 or F2. So that became 23 instead of just 20 here. Here are D's. It was D8 instead of D5. So instead of 13 here, we added 3 more. That was the 16. All we are doing is accounting for all of the electrons in each energy level. And if you use a noble gas core, that is the numbers that are next to the noble gases on that periodic table and on the pink one I gave you. Then we go to what you write in that last period, and we add them in. The 5, there are 2 added. The 4, there are 8 added. So on and so forth. Okay? Questions?
Wait, the charges when stable. I did chlorine and sulfur, but wouldn't they be positive?
No, they would not. Fluorine has never been positive. Fluorine has always been a negative 1.
So when it's
Sulfur
stable,
has always been a negative 2 because when they are stable, nonmetals always gain electrons. So they gain electrons, they become negatively charged. That is all of these up here. There are their charges.
oh. So are
Now
they
the metals become
they stay
positively.
negative?
What?
They stay negative?
Well, remember,
They stay
atoms are gaining electrons or losing them to become
stable.
stable. Metals need to lose electrons to become stable because they only have 1, 2, 3 electrons in their valence shell. It's easier to lose those than it is to gain 5, 6, or 7. The nonmetals have 5, 6, or 7 valence electrons. It's easier for them to gain 1, 2, or 3, become a -1, a -2, or a -3, and become stable that way. So if nitrogen gains 3 electrons, it becomes 10 electrons, just like
So
neon.
if they lose, they become positive.
If they lose, they become positive. If they gain, they become negative because the electrons have a negative charge. Good. Other questions? Please don't look at me like I'm crazy. Please ask questions instead. Now, I will tell you, it is very possible that I will give you a configuration like this. The K has this many, the L has this many, the M has this many, and you will have to find what element it is on the periodic table. Now, here's the good news. It cannot end up in the D's or in the F's. They are not on the periodic table test we are taking. Here's the other good news. If you simply add up all of these numbers, 2, 8, 18, 13, and 2, 10, 28, 41, 43, it tells you what element I'm talking about on the periodic table by simply adding them up. So, again, if I give you all these and I put numbers in them, add them up, figure out what element I'm talking about, and put the correct answer where it belongs. Now, this wouldn't be part of your test, but let's say I gave you 54 electrons total. Put the right answer there. Put the right answer there. Questions? Now, ladies and gentlemen, you should have out your yellow sheets. You should have out your pink periodic tables. You should have out anything that you are writing things down on for the test, because we're going to go over those questions that I asked you at the beginning of the hour. So let's do that, ladies and gentlemen. So here we go with that. All right. What monatomic element does not have 8 electrons? Now, if you did not write this down, ladies and gentlemen, on this periodic table, this one right here, under group 18, what is the name of group 18? Noble gases.
Oh, we did write it down.
Oh my gosh, we did. Noble gases are stable. They are unreactive. They are monatomic. They are inert. Okay? So, those are the clues that I could give you that will get you into group 18. So when I say that it is monatomic here, monatomic means we are talking about the noble gases. Stable would mean I'm talking about the noble gases. Again, beginning stable. Other things can become stable by gaining 2 or 3 electrons, by losing 2 or 3 electrons. Noble gases are already there. They are already stable. Okay? Now, every element that is stable has a full valence shell. A full valence shell normally means 8 electrons. However, there is one noble gas that is stable with fewer than 8 electrons. What is it?
Helium.
And it only has how many?
2.
Why only 2? Because you can only fit 2 in the first energy level. So the first clue, ladies and gentlemen, gets us to the spot currently occupied by helium. Now, the only thing you're missing on the test from this question would be the element named after the man who gave us the law of octaves. Is a monatomic element that does not have 8 valence electrons. That is the only thing that is missing. The part where you figure out which of those 51 clues on your yellow sheet are you putting in that spot. Questions? Law of octaves?
Oh, we have to find it.
Well, we might as well.
Newtons.
Newlands, thank you. Okay? All right. What element is currently in the following spots? The same period is the number that represents a d orbital. What number represents a d orbital?
2.
2. How many d orbitals are there?
4.
10.
D orbitals.
5. How many electrons fill the d orbitals? 10.
10.
You could fit 2 electrons per orbital. There is a difference between the number that represents a d, the number of d orbitals, and how many electrons fill the d orbitals.
Wait, the orbitals are the 5.
The orbitals are the 5 different orientations that the d's can be.
And then the 10 is.
The 10 is how many electrons will fit in there. Okay? And the d is represented by the number 2 because an s represents the number 0. A P is represented by the number 1, a D is represented by the number 2, and then finally, an F is represented by the number 3. So we are in the second period. Shows sp3 hybridization with a bent geometry. sp3 hybridization begins with what family? What family do we start getting sp3 hybridization with? So it's carbon, nitrogen, oxygen, or fluorine. It's got to be one of those because those are the only ones that are sp3 hybridization. The only one that is sp2 hybridization is
Boron.
the boron family. And the only one that is sp hybridization is the alkaline earth metals. Okay? So, shows sp3 hybridization and a bent geometry. sp3 hybridization, but tetrahedral. sp3 hybridization, but trigonal pyramidal. sp3 hybridization, bent geometry. So it's oxygen. sp3 hybridization, linear geometry. Questions?
Wait, why wasn't it? Oh, the carbon. Never mind. It's sp2.
Okay. Is the smallest atomic radius of any metal in its family. Where? Sorry, go ahead.
I was just wondering if I could use the bathroom.
Has it been 10 minutes?
Yes.
Okay, knock your socks off.
Okay.
Smallest atomic radius of any metal in its family is going to be where?
The top right. The top.
In a family, where is it going to be?
Top.
At the top. Now, normally, that would mean up here. However, remember, when we get under the stairs, this one is at the top of its family, this one is at the top of its family, that one is at the top of its family. Right? Questions? Okay. 5 valence electrons. What family has 5 valence electrons?
The boron.
The nitrogen family has 5 valence electrons. 1 valence, 2 valence, 3, 4, 5. So what element am I talking about? Sp, I'm talking about antimony. Questions? So now I put in trends, put in knowing what an atomic radius is, put in knowing how many valence electrons each family has. Its electron configuration ends P4 and has the highest electronegativity. Okay, what family ends with P4? What? The oxygen family. P1, P2, P3, P4. Highest electronegativity would be where within the family? Top or bottom? At the top. So we are talking about the spot of oxygen. Questions? Okay. This one is a harder one. You have to put some ideas together here. In the same period as the valency electrons in the carbon family. All right, what period is that? Carbon has 2 valency electrons.
Four. The four.
Carbon has 4 valency electrons. So we are in the 4th period here. Now on your test, ladies and gentlemen, what I would do is over by the 4th period at the end, I would write down what clue is going there because you know it's somewhere in that period. If you can't figure out where in that period it goes, at least write it down on the side so you know what, if I fill in the other 7, the one that's open's got to be that clue that I'm missing. So keep that in mind. But I do give you a way of finding it with these ionization energies. What is ionization energy?
How much energy it takes to like dump a electron max level?
You're close, not to jump it to the next level, but to get the atom to what?
Remove electrons.
To remove electrons. Good. Now, take a very close look at the numbers and which number doesn't fit a pattern that is semi-established there. Which number seems out of place in the order that they are going?
900.
Why the last one?
Would it be the
I don't know how to
900?
explain it.
No, this one was not an even number. Cynthia?
900?
Why the 900?
I don't know. I'm just guessing.
I agree with Sophia.
It just seems off.
It's not really one that's like a whole like 100. It doesn't have like any like extras.
Nope,
What do you mean?
doesn't matter. Doesn't matter. It's not what you're looking for.
What is kg?
Kilojoules. Energy.
It just jumped and made sense.
350.
Why 350?
Because it goes 2, 4, 5, 8, 0. Shouldn't it be like 360?
Oh my gosh, you're looking at a pattern going with just the second number in the number, going 1, 2, 5, 1, 4, 5, 8.
Oh, 780. That was a high jump.
What?
Yeah, it went from 3.
I still said 7.
2.
How much is the difference there?
115.
100 something.
125. 15. 105. 420.
Okay, I'll do the right math.
I'm close.
Yeah, you are.
120. 135.
Which one is out of place?
The 430.
The 120.
So the 780.
So all of a sudden, it takes a little over 100 kilojoules of energy to remove an electron. A little over 100 kilojoules, you'll remove an electron. A little over 100 kilojoules. All of a sudden, it takes 430. Why? Why would it be so hard to remove that electron?
Because it's the last energy, because it already has enough. And it doesn't want to remove another one.
Okay. It had to have become stable. And now all of a sudden you're getting it to remove an electron after it has become stable. So this is the highest which ionization energy? Which one is this? No. This is the first, second, third, fourth. What family has the highest fourth ionization energy?
Boron. Isn't it boron?
Group 13. Okay, so what period were we in?
4.
And now group 13,
GA.
Gallium. Oh.
period 4, group 13. Yes, we are at gallium, ladies and gentlemen. We are at gallium. The first part of the clue got us to period 4. This part of the clue gets us to group 13. That is gallium. Questions? Okay, our last clue. These two elements are next to each other on the periodic table, even though they differ in atomic number by 11. Tell me the elements that differ on your periodic table by 11.
Ca and Ga.
Ca and Ga?
SR.
SR and... Okay, so the second part of the clue. They are in the period where the f orbitals first exist. Period 4. Very good. So, calcium and gallium. Now, I would have to give you a way to distinguish which one goes first, but that is where you would put them.
On both of them?
For this last clue. One would go into calcium, one would go into gallium. Questions?
So that's it?
Well, no, but that's examples.
Okay. Well, yeah, but
Now, you did something really good. Because when do F's first exist? In the 4th energy level. When do F's first fill? In the what? In the 6th energy level. So there is a difference between when they exist, the 4th level, and when they fill the 6th level. The same is true of the... When do the D's first exist?
4.
No.
The 3.
D's exist in the 3rd energy level. When do they first start filling?
The 4.
In the 4th energy level. So there is a difference there. They are the 3 D's. They are the first D's that we have, but they don't start filling until the 4th energy level. Questions?
So wait, so our answer would be half of our answer would go in Ca and the other one in...
Well, it would be 2 separate clues. So now the last part might be this element has a smaller atomic radius.
So you just didn't give...
Which one has a smaller atomic radius? Ca or Ga?
Ca.
Ga. Atomic radius goes down as you go across the family. Okay? So again, and I did tell you that for the low price of 2 points, you can
Claim 1.
buy an answer. So instead of getting both wrong, you could come up and go, Mr. Brand, place branium.
So technically, if you tell us like what we need on our grade, we can just buy up to what you gave us, and then we can just use that as our test.
Sure, but you're not leaving yourself any room for error. You better not make a mistake on any of the ones that you placed then. Maybe one of the ones you asked me about was a very easy one.
Oh, yeah.
So it's your choice. You can do whatever you want. You want me to fill in all 50 on the test for you, I will, and I'll give you a 0. I have no problem with that. Well, that would be the other option. Why even bother then? Unless you want to annoy the heck out of me during the test, but that's your option. I'll be here either way. Questions? Good. So, ladies and gentlemen, then we need to go back to this and let's talk about this. Now, inter and intra are on your yellow sheet. Intra is between different atoms, forces that are holding atoms together. Okay? There is an intrastate system within the United States of America that goes from one state to another. A road that goes from one state to another is called an intrastate. TRA. Then there are roads that only go within a state. Those are called interstates. Okay? So an intramolecular force is a force between 2 different atoms. There are 3 kinds. There is covalent network solid. This is the strongest one, but we are basically saying the only thing it can be with is what 2 elements? Really, what 1 element?
What?
What element exhibits covalent network solid forces?
What does that mean?
What element in the periodic table exhibits covalent network solid forces? Carbon. Carbon. Why? Because it can form 4 bonds. No other element on the periodic table can form 4 bonds the way carbon does. The next closest element to be able to do it would be what? No. Silicone, which is right under carbon. Okay? So It could happen to carbon atoms. It could possibly happen with silicone atoms. It wouldn't go down 1 to tin. Why? Tin becomes a metal. That's not going to happen. Okay? Covalent network solid are the forces that hold a diamond together, ladies and gentlemen. A diamond is the strongest naturally occurring substance on the planet. And this is why, because these 4 bonds hold the carbon atoms strongly to each other. Okay? That is why. The second type of bonding is an ionic bond. An ionic bond is the strongest bond, and it is between a metal and a nonmetal. And metals become positively charged and nonmetals become negatively charged. And because of those charges, they can hold the atoms together incredibly strongly. Strongly? Yeah, good. We'll go with that. Okay? Because they're opposite charges, actual opposite charges of +1 and -1, +2 and -2, they are strongly held together by those charges. Now, if you are debating which ionic bond is strongest, as a general rule, we are going to tell you that the one with a higher formula mass will be stronger than the one without. Questions? Now, the third strongest force, intramolecular, is a metallic bond. Now, metallic bond is what holds metals together. Most metals are in what state of matter? Solid. Well, to be a solid, there's got to be something holding the atoms together. For that pipe to be a solid, there has to be some force holding it together. And it's a pretty goddamn strong force. Why? For me to melt this pipe, I got to get it up to about 2,000 degrees Celsius. To even make it so that the forces holding it together will allow it to become a liquid even. And to become a gas, probably about 3,200 degrees Celsius. That is a strong force. And it is created by what we call a sea of electrons, which is why metals are conductive to heat and metals are conductive to electricity. The electrons just kind of float around. Why? The metals want to lose electrons. Now, another metal will not take that electron. But the metal is like, here, I'm going to push my electron off onto you. The problem is when it does that, it becomes charged, and boom, another electron comes and takes its place. So we call it a sea of electrons. They're moving around along the metal. Okay? Again, the relative strength of metallic bond is dependent on the formula mass. So, based on the periodic table in this pattern alone, and are there exceptions to this pattern? Yes. Are we going to worry about them? No. Based on that alone, copper is not as strong as silver, which is not as strong as gold. Why? Copper is the lightest of those 3 metals. So even though it's held together very strongly, if you were comparing those 3 metals, copper would be the weakest of the metallic bonding. Questions? Okay. Then we get into intermolecular. Intermolecular are the forces of attraction between molecules. Molecules are covalent bonded. So technically, if you wanted to go back, what would be the 4th one on this list between atoms? A covalent bond. But covalent bonds then become intermolecular forces, intermolecular bonds. That is on your yellow sheet. These are forces between molecules. The other one was forces between atoms. The relative strength of the intermolecular forces depends on the formula mass. That's what we're going to use for all of these. So if you're debating between 2 ionic bonds, 2 metallic bonds, 2 covalent bonds, which one has more mass? That's a stronger force holding them together. Fair enough? Good. Now, there are 3 types of forces that hold covalent compounds together. The first is hydrogen bonding. Hydrogen bonding is not on your yellow sheet. But please understand this. Hydrogen bonding is between hydrogen and nitrogen, oxygen, fluorine, and chlorine. Now, it wouldn't surprise me on a quiz or on your test to say this third period element can display hydrogen bonding? What is the only third period element that can display hydrogen bonding? Chlorine. Boom, that's an easy one. You know exactly what spot I'm talking about. This group 15 atom can display hydrogen bonding. What group 15 atom can display hydrogen bonding? Nitrogen. What group 16 atom can display hydrogen bonding? Oxygen. Which group 17 atom can display hydrogen bonding and has the highest electron affinity? No, not chlorine. Fluorine. Fluorine. I'm sorry if you said fluorine. I heard chlorine. Questions? Okay. Go ahead.
Never mind, I don't-
No, ask it, please.
No, I don't know what I was gonna ask.
Okay, then I can't answer it.
Why is
I'm sorry, Sophia, I didn't get that.
you know like how chlorine is Cl, but fluorine Fl?
That's how the
The person who you would have to ask in the science department is Mr. Hendrickson. He is great with all the names and symbols and can even tell you where the Greek or the Latin root comes from. I cannot, sorry. I don't know. Probably because chlorine couldn't use just C because carbon already had taken it. So, your choice. Van der Waals forces, yes.
Can I go grab my computer charger?
Sure, go for it. What the heck? Okay. Van der Waals forces. Medium intermolecular forces. Strong intermolecular forces, medium. And these are between polar covalent compounds. Now, why did we show you this? Why did we show you this? And why did we show you this? We showed you these because these lone pairs mean that there is going to be a polar compound. Lone pairs around the central atom mean that it will be a polar compound. So the polar covalent compounds are in the nitrogen family and are in the oxygen family and can be in the halogen family unless one thing, ladies and gentlemen, unless one thing, and that is this. In the halogen family, we need to be careful because halogens can exhibit symmetry. Symmetry means that if you cut them in half, put a mirror in front, one side would look exactly the same as the other. So if you put fluorine with, sorry, can't do fluorine. We'll explain why in a second. Let's do bromine. You'd figure after a while I would get used to you have to double click it. If we do bromine with, I'm sorry, Sophia?
Why don't you just like add the two things?
Add the two things.
I don't know, what do you call them? The semicircles of the B? The round part? Because you already had the F. Why don't you just, because you're having struggle erasing it, why don't you just...
Oh, I didn't think about making the F into a B. I'm sorry. Okay. Now, here's the reason I couldn't use fluorine. Why? Because fluorine wouldn't be Van der Waals forces to begin with. Fluorine would be what?
It'd be hydrogen.
Okay. So around this atom right here, ladies and gentlemen, this one, are there lone pairs around this central atom? Here, here, and here. Yes. This is a polar compound. But let's do this. Okay. Which one is the central atom? What? Either one. Are there lone pairs around this one? Are there lone pairs around this one? Is this a van der Waals forces? No.
You said that if they were bad, there was.
I did, but I said if they lack symmetry. If I put a mirror right here, see the electrons that you're getting? What would the other side look like? The same. If I put a mirror here, it's going to look exactly the same. That is symmetry. In other words, the diatomics, because they are the same kind of atom, will not have, even though they have lone pairs, they will not display van der Waals because they have symmetry. Okay? So, if we put bromine with hydrogen, yes, it has polar compound. It has the lone pairs. But when you put it with itself, it is not, because of the fact that you've got symmetry here, you've got symmetry here. Does that make sense? Yes?
Yes.
But there's no way you can have symmetry with the oxygen family. Okay? You cannot have symmetry with the nitrogen family. There is a lone pair there. That is going to make it a polar compound. Okay?
So if they lack symmetry, that means there are polar compounds.
If they have lone pairs and lack symmetry, they are polar compounds. If they have lone pairs but have symmetry, they are not. Now, is this polar? Why not? It doesn't have lone pairs. Is this polar? No, there are no lone pairs here. The charges are spread out. No lone pairs, no polar. Is this polar? Even if it were, when you cut this in half, what do you get? You get symmetry. Okay? So you get symmetry in these. Questions? Okay? London dispersion is the weakest type of intermolecular force. And it is between two nonpolar compounds. Those would be your diatomics. Okay? Those would be your diatomics. Okay? Symmetry, no lone pairs around the central atom. So, along with things like the tetrahedral shape for carbon, the trigonal planar shape for the boron family, the linear shape for the beryllium family, and the 7 diatomics, those are all London dispersion forces holding them together.
Wait, I thought it was 8 diatomics. Oh, wait, 7, yeah. Never mind.
Questions?
Wait, so this one means that they're symmetric. And
They're
they don't have
symmetric,
lone pairs.
well, first of all, they don't have any lone pairs. There are no lone pairs. That's one.
So like lone
But if there
pairs-
are lone pairs and there is symmetry, meaning your diatomics, those are still London dispersion forces. Okay? N2, O2, F2, Cl2, Br2, I2, H2, those are all London dispersion forces. Questions? Yes, no, maybe so. Okay. So, we left off with this. This is the last thing that we're going to talk about. And all we're going to do here is identify what type of force is holding them together. So, H2S. What type of force is holding H2S together? First of all, is it an ionic or a covalent compound? Covalent. Please remember, hydrogen is technically a nonmetal. So, is this hydrogen bonding, van der Waals, London dispersion? Well, which one can you eliminate right away? Hydrogen bonding. Hydrogen bonding. Why? Because it's not with nitrogen, oxygen, chlorine, or fluorine. This is van der Waals. This is van der Waals. Very good.
Is that because hydrogen has one and sulfur has two, so there's one more pair?
Well, here's the thing. Sulfur will have 2 lone pairs around it because it's in the oxygen family. So therefore, it is going to be a polar compound. So this is van der Waals forces because sulfur has 2 lone pairs. Questions? LIF. What kind of bond is that? Ionic. BR2. Ionic or covalent? Covalent. Which kind? Diatomic, which makes it what? London dispersion forces. How about F2? Which makes it? Carbon, solid carbon. Can't be metallic bonding, it's not a metal. Can't be ionic bonding, there's not a metal and a non-metal. Okay, but specifically what kind? This is your covalent network solid. Silver, Ag. Metallic. NaCl. Ionic. HCl. What? But what kind of bond is it first? Covalent, ionic, covalent network solid, ionic, metallic, or covalent? Covalent, and yes, this is hydrogen bonding. How about NF3? Covalent. London dispersion or van der Waals? London dispersion or van der Waals? No. Why nitrogen? Lone pair on the top. That's going to be London. That's going to be van der Waals. Sulfur. 2 lone pairs. That's going to be van der Waals. Questions?
Wait, sulfur is 2 lone pairs?
Yes, it's in the oxygen family, right? So it has 6 electrons around it. Here they are.
Oh, yeah.
2 lone pairs. Can't be bonded with. Questions?
But wouldn't that make it 3? If you combine it with the H, that wouldn't make it 3 lone pairs? Or does that mean
No.
that one of the pairs is
You can't change the amount of lone pairs. There's 2 here. If we bring in a hydrogen,
the
it's
same-
not going to change the amount of pairs around. It's not going to change the amount of lone pairs around the central atom. It's going to add 2 bonding pairs because now this pair is shared between these 2.
So it can only be the same there, like not combined with anything else, and there in the beginning.
It can only be the same.
Because sulfur already has 6, so it already has that pair. As long as it's not combined with something else, then that's a bond, right?
These pairs up here cannot bond with anything because they're doubled up in their area.
Yeah.
So those will never make a bond. To share electrons, you've got to be willing to give an electron to get one back. You can only do that if they are unpaired in an
So
area.
that wouldn't be a bond though, because you're sharing and like.
This is a bond. That is what a bond is. A bond is 2 different atoms.
So what are the red ones?
They're the lone pairs.
Oh, okay. So if we have 2 from 2 bond of 2 different ones, it can't be a pair because it's not the same thing.
Well, there's 2 kinds of pairs. Lone pairs, which is what this and this are, and bonding pairs, which is what this and this are.
Right. So
4 total pairs,
but they're different types.
2 lone, 2 bonding, sp3 hybridization, okay, and a bent geometry,
Okay.
just like oxygen.
Oh,
Good. Questions? All right, take out your worksheet packet, ladies and gentlemen, and let's look at worksheet number 7. Now, I am sorry, ladies and gentlemen. Some of the worksheets that I have gotten for you I've been making adjustments to them as I go, which does not affect you because they were already printed. One of the first adjustments I would make on this one, ladies and gentlemen, is I would do this. Down the side here, I would write 1, 2, 3, 4, and 5. And on the top, I would put 1, 2, 13, 14, 15, 16, 17, and 18. And the reason I would do that, ladies and gentlemen, is because those are the periods and those are the groups. And it isn't even a bad idea on the other side to put the numbers if you want, but I don't have room. So the most metallic element is element X. Where does that go? I'm going through this with you. You may want to follow along. You may want to do it. The most metallic element is element X. That is question 1. Where is the most metallic element? Where is the most metallic element? The lower left-hand corner of the periodic table. X goes right here. Now, granted, on your periodic table, this is a little bit smaller version. On the one you will be taking your test on, that would be period 7, group 1, lower left-hand corner, okay? Since that's not on here, the one that, in this case, the one representing cesium, or I'm sorry, rubidium, that is the one that is the most reactive metal on here because it's a little smaller than normal. The most reactive nonmetal is I. What element is the most reactive nonmetal on our current periodic table?
Wait,
Fluorine.
but it says not or like metallic, or is that the same thing?
Non-metallic, non-metal, metallic, metal, same thing. Okay? Thank you. Thank you. Okay? Now, when I talk about slam dunks, ladies and gentlemen, these are the ones that if you put in the wrong spot, you are going to be the person who gets the 2, the 8, the 6 on this test. Because those are the easiest ones. And guess what? If you put something else in those spots, it messes you up. So now you're, instead of getting 1 wrong, you get 2 wrong for every one that you put in the wrong spot. Think about that. Elements B, L, W, J are all unreactive gases. Where does that mean they go? Jennifer, what can I do for you? Go ahead. Again, it's your choice, guys. I'm just going over this stuff, which is incredibly important for you, but go. B, L, W, and J, where do they go? They are the noble gases. So I am going to write them right below. Now, here's the other thing. On a test, if I don't give you enough information to place the clues right away, you can bet that the next question or 2 will do that. I'm not going to have you write these down here and then on, that was question number 3 on the test, and then on question 18, I'm going to tell you how to place those. No, it will be the next few questions, just like B is the lightest. Where is the lightest? B goes at the top. By the way, on your yellow sheet, you may want to cross out the ones you've been through. Or, even better idea, ladies and gentlemen, is to write down what clue you thought they were, because then if you mess something up, you can find the clue number. The clues are going to be numbered. I don't care. But the other thing is, if you cross off all of your elements, and I will give you another one on that day, a list. If you cross off all your elements and you can't read them anymore and you mess something up and now you're erasing, that's on you. So I can give you a second sheet of the yellow elements where you can just cross them off as you go and it won't have all your writing and stuff on it. Fair enough? Good. Excellent. W has a larger atomic radius than either J or L. So where is the largest atomic radius? The bottom. So that means J and L are going somewhere in there, correct? All right. L is in period 2. Then J has to go below it. Process of elimination, correct? Good. Questions? The lightest element of all is A. God, I hope you don't get this one wrong.
Helium.
God, you just got this one wrong.
Hydrogen.
Okay, it's not going to happen that way on your test.
Are you sure?
I'm positive because
We don't have.
we don't have an A.
We have an AM.
Okay, but that's not an A. So again, I was right. You could just go with that. Sigma is a third period element that is highly reactive with water. What third period element is highly reactive with water?
Sodium.
The alkali metals. There you go. There's sigma. H, K, M, that is supposed to be an O, not a 0. Y and Z are all third period elements. So, okay, in the third period, H, K, M, O, Y, and Z. H has a larger atomic radius than M, even though they differ in atomic number by 1.
32.
Oh,
Well, that could be anywhere.
Yeah.
The next thing isn't it?
13,
Why?
15, 16, or
The large atomic radius is N.
All that means is those two are next to each other, and which one comes first? H. H and M are next to each other. They could be anywhere on here. They didn't talk about ionic radius. K is a good oxidizing agent. Where are the good oxidizing agents?
Isn't it like the fourth period at the bottom left?
Okay. Oxidizing agents are the nonmetals. Put it over there by K. Or I'm sorry, in group 17. Takes care of K. Y is metallic, but is often considered a metalloid. Where are you metallic but a metalloid?
the right or left side of the zigzag line.
The left side of the stair step. So Y goes here.
One on the second spot.
What?
One in.
Well, because it says it's considered a metal.
Oh, okay.
So it's got to be on the left-hand side. Thank you.
Well, couldn't there be 2 different spots though?
Where's the other spot where it's touching that yellow line? Or the bold zigzag line?
It's germanium and antimony. I can't tell if it's.
Okay, but remember, one of those is a metal and the other one is a non-metal, right? Which two are you talking about?
Germanium and antimony. They're both below the.
Germanium and antimony.
And they're both labeled as metalloid. I don't know.
But which one of those is in period 3?
Oh, that's a good point. Never mind.
Okay. All right. O has 6 valency electrons. 16. Which means now what do I know about M and H?
They're 14
They're in 14 and
and 15.
15. Why?
Because of those 2 terms.
Because that's the only ones where they're next to each other to be having atomic number differ by 1. Which is first? H or M? Which means if I put H and M there, what's left? Z goes here. There you go, ladies and gentlemen. Questions? C has an atomic weight of 5 and forms the compound Ci. Okay, 2 ways to get this. 1, if its atomic weight is 5, what does that mean? Where on the periodic table? It's at the top. Okay? Now, what is the charge of I? -1. So what would have to be the charge of C to form the compound Ci? +1. Now, there are multiple spots in the +1, right? Where does it have to go? Has to go at the top. Why? Because that is the only spot where it could have an atomic weight of 5. A light atomic weight is near the top. Questions? Do you see how you're putting multiple ideas together? Okay, good.
We forgot number 13.
Sorry, G has 7 protons. How do I find that? Yeah, that's the same as the atomic number. What element has 7 protons? Here's the other thing. 1, 2, 3, 4, 5, 6, 7. There you go. There you go. E, Y, R, and omega arranged in increasing mass are in the same family. So which one of those is already in the periodic table? So to be in the same family, they need to be how compared to it? And they're arranged in order of increasing mass. So, yep. There you go. Lightest to heaviest. They were arranged that way for us. All right, next. Delta is the heaviest of all elements and is radioactive. Where would that be on this periodic table? What? It's the last element. The heaviest of all has to be the last element, right? Delta. There you go. Mr. Brand. Yes, I do. Okay, we'll do. All right, bye. Iditsi, get out. You need to leave. They said they don't want you here anymore.
Where are you going?
Geez, you're kind of nosy. I wouldn't embarrass her by asking her a question like that. Get out. They don't want you here anymore. Go.
I'm packing my stuff.
Okay. P is a fifth period element that is weakly basic when mixed with water.
What's not
It's an X.
It's in family 2.
It's not family 2. It's the alkaline earth metals, or it's in group 2.
Okay, group 2.
But also, these are the ones that are slightly reactive with water, and they do create a base. Thank you. Have a good day. We'll see you tomorrow. Bye. She's mad at me now. Okay. D is the second period element that forms the salt Di2. What again is the charge of I? So what does that mean the charge of D has to be if it's Di2? No, that would be Di. You can't put two negatives together.
Plus 2.
Plus 2. Di2. There are 2 negative 1s. That is a negative 2 charge. That means this has to be a positive 2, and since there's only one of them, it must be a plus 2. So, there you go. On the bottom, what did I, oh, because it said it was a fifth period, right? No, what did it say? Fourth period? Second period.
Second
No,
period.
don't tell me I'm wrong when I'm right.
I was just confused why it couldn't be the bottom.
All right. F is used in both jewelry and writing utensils on Mars and is in the same family as T, H, and Delta. What element is used in both writing and jewelry on Earth? What?
Carbon.
Carbon. Diamonds, graphite for your pencils. Okay. So F goes here. H and Delta are already there, which means T goes there. I don't know. Maybe it pays to buy one on a question like that. The most essential Martian liquid is A2N. What is the most essential liquid on Earth?
Water.
So A is already in hydrogen spot. What does that mean?
Oxygen.
N goes where oxygen is supposed to. I know I forgot to cross off a bunch, but I'm trying to get done. A acts like a metallic compound such as AV and a non-metallic compound such as F4A. So what is A? Well, what element is it?
Hydrogen.
Hydrogen. So when it's acting like a metal, what's its charge?
Plus 1.
So what would have to be the charge of V? Minus 1. Got to go in group 17. And when it's acting as a non-metal, what's its charge? Negative 1. So F must have a charge of?
Plus 4.
Oh, it's already there. Okay, never mind. Du is a common Martian substance. Well, here's D. That is a plus 2. U would have to have a charge of? Only one spot left there. Okay. Sigma forms compounds such as sigma I2, sigma 2s3, and sigma U. Okay. Well, I is what charge? So what does sigma have to be if it's sigma I2, just like this one here? So here's sigma. And then S would have to be,
And 15 because Q goes in the first one because you forgot to write it down.
did I forget to write it down? Oh, there you go. Then we're done. Good, excellent, wonderful. More practice tomorrow, ladies and gentlemen. Goodbye, goodbye, goodbye. Go away. See ya. Thank you.